Greetings. Welcome to week 2 of scripting. We have a lot to cover today, so let's going to go ahead and just jump on in. As we did last week, we're going to go over the terms, key terms first, get a kind of a feel for what the unit's going to be about, and also kind of give you a prep so when we get into this next phase of the video, okay, that that you have a better idea of what are the terms that we're going to be using. Okay, so as you can see on the screen, week 2, key terms, PowerShell, scripting, object. For those of you who have taken any kind of OOP or are currently taking OOP, the definition of an object for object-oriented programming is the same definition as here for the object. Structured data items, PowerShell contains properties, data, and methods, action. Everything in PowerShell is an object. Keep that in mind. It's not data. Everything's an object. Pipeline, a way to pass the output of one command directly into another command using the bar symbol. Variables, name storage locations that hold data so that it can be reused later in a script. Making scripts intelligent, adding logic, conditions, and loops so the scripts can make decisions instead of just running fixed commands. Writing scripts, creating a sequence of PowerShell commands saved in a .ps1 file to automate tasks. Capture, capture, manipulate, command output. Store the results of a command in a variable and modify, filter, or analyze it. Filter and evaluate system data. Select specific data from command results and test it against certain conditions. Repeat actions automatically. Uses loop to perform the same task multiple times without manual intervention or manual repetition. Make decisions based on conditions. Use conditional statements to run different code depending on whether a condition is true or false. Automation, using scripts to perform tasks automatically instead of manually. Reporting tools, scripts or commands that gather system information and present it in a readable format. Tables, files, CSV, reports. Core technical items. Declare and use variables. Create a variable, for example, $name equal John, and we'll be talking about that a little bit later, and reference it later in the script. Data types, the kind of data stored in a variable could be string, integer, Boolean, array, object. Commandlets, built-in PowerShell commands designed to perform specific system tasks like get process. So predefined programs that we can use that automatically will do things for us. Where object, a commandlet used to filter objects in the pipeline based on conditions. If and switch. Condition statements used to make the decisions in scripts. For each and while, loop structures used to repeat actions. Control flow, the order in which commands execute in a script, including decisions that are made and loops that are occurring. PowerShell is powerful because 1, everything is a project. 2, commands connect using pipeline. 3, scripts can make decisions. 4, scripts can repeat actions automatically. 5, data can be filtered, evaluated, and reported. Okay, this week is focusing on adding logic and structure to this automation that we started. Okay, so again, as always, I want you to memorize these items. I want you to know them by heart. So when you see them again, you will know exactly what's happening, at least as far as the definition of what they're doing. Okay, so let's jump into the week 2 video, lecture video. And wrong one, sorry about that. Here we go. Okay, so week 2, we're going to be talking pipelining, variables, control flow, variables, data types, pipeline, if switch, all the things that we just covered in the definition of terms. The script is conversational, okay, demo friendly, builds directly from week 1. Okay, welcome, week 2. Last week we learned what PowerShell is, how to use commandlets, how to discover commands, how to write and execute basic scripts. But as we know, scripts were the ones we worked on were mostly linear. This week we're going to basically juice it up, okay, and give it a lot more power than just the regular linear script. You'll learn how to store data in variables, pass objects through pipeline, make decisions using conditionals, repeat actions using loops. Okay, this is where scripting becomes automation when we add these features to our scripts. Part 1, variables and data types. Let's talk about variables. A variable stores data so that we can reuse it. In PowerShell, variables begin with the $sign. So for example, I can have $name and load it with a text mac, $age, which is an integer, make that 25, and is admin, I can load that with a Boolean of $true, so $true and $false. Okay, so explaining, strings or text, and this is really no different than any other programming language. That's one thing about a lot of languages. The basics of what a language does is the same. How they do it or the syntax they use could be different. So as far as, fields and characteristics, strings, integers, Boolean arrays, there for like any other language, like object-oriented programming for Java, for C++. Okay, this one is for PowerShell and for scripts. And so, for example, here I'm loading an array or a list with 1, 2, 3, 4. And then from that, here I'm loading processes into a list. Okay, so each one of this is an object that I'm creating. Okay, just here, we did not store text. We actually stored objects because we told the system to get for us processes that are currently operating or running on the system. Here, check. Okay, here I'm actually getting one of the fields from a process object. I'm getting I'm getting the count of the number of processes that were loaded up in this particular case. Okay, variables allow us to capture output, modify data, reuse results, avoid repeating commands. Without variables, scripting becomes very, very limited. Okay, the PowerShell pipeline, the bar. Okay, here the pipeline symbol is the bar. It passes objects from one command directly into another command. So in this, for example, we say get process. So this is basically gets us all the processes that are currently running on the system. And what this is, we're going to pass that to sort object by CPU descending. So based on the CPU time that is actually being utilized, we're going to take those processes and sort them. The bar says that I pass each one of those processes to the sort, and then that sort is where we're going to actually take that information and sort it. So over here, get process produces objects, sort objects, sorts them, object moves through the pipeline right there. Okay, here now we're using a filter. We're introducing a filter where we're getting the process, but we only want processes where the object has a CPU time greater than 100. So that's one of the filters that we're doing. Break it down, where object filters, $_ represents the current object. .cpu is a property or characteristic of the object. This is not text filtering. Notice this is a structured object filtering. I'm taking an object, I'm taking a definition, one of the definitions within that object, and using it as criteria to retain the object. So we're not really looking at text filtering, but we're looking at object filtering. That's why PowerShell is so powerful. Okay, so we can combine things. Here we're getting the process where the given object that we have as a CPU greater than 100, and if it does, then we're going to run it through another object, or excuse me, another process that will take that information and sort it. So I'm going from getting the process to filtering it to sorting it, all in this one line. In this particular case, we're just sorting descending. Okay, this is chaining logic. Okay, it is automatic automation building is what we're doing. Because again, we're going to be able to store this as a .ps1 file, then actually schedule this to where it runs on a regular basis. Condition logic for if and switch. Okay, if, for example, here we got a dollar threshold, we set it to 100, and we say if the CPU threshold is greater than 50, okay, we want to write high threshold. Okay. So in this particular case, this one is we're actually just setting a field, and if that field is greater than 50, which it is, since we set it to 100, okay, we're going to write high threshold. But we could make that, taking that from a list, and in that list, depending on what was in the list and what the objects we have, we can basically filter that down, similar to what we previously did. Explaining comparison operators, -GT is greater than, -LT is less than, .EQ is equal, and .NE is not equal. And certain sort of things that you would see in a regular programming language, not regular, in another programming language that we're also using the same type of architecture, same type of script. I don't use script, same type of context that we want to use for scripting. So here we're doing this. We're creating a field called high CPU. We're told to get all the processes. We're only going to accept processes from objects where the CPU time is greater than 200. Here we're checking, you say if high CPU, which means it's greater than 200, then we're going to take that, list the information about the process with a warning of high CPU process detected. Here, right host writing system. And just want to make clear, this particular one we're doing here, all we're doing is telling that we found a process that exceeded the CPU. We're really not printing any information here, okay, about the object that we actually detected to have that high CPU. So here we're going to say, yeah, we detected a high one, or we just detected and the system was operating normal and there were no processes greater than 200. Okay, so this is decision-based automation. So, okay, we can also use a switch in using the comparison one variable to multiple variables. Let's say that we set the status to stopped, and we switch based on the status. Okay. If it's stopped, we write services stopped. Again, think of this as being, instead of just setting the status field, that we're actually reading objects from, say, processes. Based on that, based on the status that's coming through from those objects, we can either set that it's running, it's stopped, or it has an unknown status. But we're switching based on the status and the categories that are available. Okay, where do we need switch? When you have known categories. It's either going to fall in category A, category B, or category C. That is when we can use switch as far as one of the filtering criteria. Okay, for loops, for each and while, automation requires repetition. Here, first for each, we're looking at services. We're loading all those objects into a list for services. And then for each service in the list, Okay, we're going to write the service name. So we're looping through these services here and taking that and writing the name of the service. Okay, loop through collection here. Dot servers represents one item at a time. Now filtering inside the loop for each service in the services collection. If the service status is equal to stop, then we write out that the name of the service and then that particular service is in the stop status. This is structured evaluation. While, okay, while has the same sort of thing. While something is true, okay, we're going to do something. Use when repeating until condition changes. We set the count equal 1. We said as long as our count is less than 5, okay, we're going to write out host and the count, and then we're going to increment it by 1 and go back and go to the top of the loop and run it again. Okay. Incremental operator, the difference between for each and while. For each says iterate over a collection. While says repeat while a certain condition is true. Okay, so combining everything, okay, combining variables, pipeline conditions, and loops. Here's an example of a little mini script. Here we're taking a threshold of being 150. We're getting the processes, putting it in the collection of the collected processes. We're taking the high CPU process, we're creating a variable, running down through the processes. Okay, we're going to pass that process over. We're going to check to see if the CPU is greater than the threshold that we set. Okay, if the particular CPU count is greater than 0, okay, then we're going to say, we're going to write high CPU process detected. And then for each process in the high processes, we're going to take that information here and we're going to write out the process name and the actual process CPU amount. Okay. So we're using the if, we're using the for, we're using the passing of the pipe into the pipeline, and we're using variables. So this particular script is one we would save. Okay, and here. The one we would save, and this is really an executable script that we could possibly use, and it is what you will be designing. In your homework assignments and your project assignments, you'll be basically getting to this level and defining scripts and to make sure they do what the requirement suggests. Okay, so this is just saying what we said. It collects data, filters, makes decisions, loops results, displays output. This is where we're going from transition from beginner to scripter. Okay, 3 things, common mistakes. Keep this in mind. Put it in your book. Okay. Students often forget to put the $sign before the variables. Confuse equal with equal. Okay. Forget putting the brackets in. Forget dollar underline for pipeline filters. Overuse write instead of returning an object. Remember, automation is about structured thinking. You have to be thinking about exactly what you want to do. So in closing, this week 2 is critical. I want you to understand variables, pipeline, conditionals, and loops. And then with that, you will understand the core of automation logic that we can proceed into week 3. Okay, thank you, everyone. For those online, you will have access to this and also to the lecture video for those who are going to be face-to-face. Those who are face-to-face, this will be out here before the Tuesday of our actual class. So expectation is you would have reviewed this and that, we were basically going to take the next step of this and kind of look at a little more detail in the in-class lecture class that kind of supports what we've already discussed here. Okay, so everybody have a good one, and we will be looking at this before Tuesday. I'll see you on Tuesday. Have a good one. Bye.